All right, so guys, we're in Unit 4. Unit 4 is all about functions. Certain functions can be linear and certain functions can be non-linear. Okay, the good thing about the two categories that we look at is it's really easy to tell them apart if you have a graph. Okay, but if you don't have a graph, there's also a couple of things we can look for, and I want to show you. So first of all, a linear function is a function that will make a straight line. Look right inside the word linear. Okay, see how the word line is most of the word? All right, so linear means it's a straight line when you graph it. A linear equation also, if you remember, has this format, y equals mx plus b, right? We spent just about half of that last unit talking about y equals mx plus b, right? M is your slope, b is your y-intercept, so that hasn't changed. And then sometimes you're going to get a table, right? And in that table, if you can see a constant rate of change throughout the entire table, like this one goes from 4 to 3, and then 3 to 2, and then 2 to 1, and then 1 to 0. Okay? That's a constant change for y. Do we also have a constant change for x? Goes from 6 to 4 to 2 to 0 to negative 2. So is that a constant rate? Absolutely. Okay? It may not be a proportional relationship, right? But it's definitely a constant rate that you're seeing. So remember, you can grab the bottom 2 points, and you can do the change in y over change in x to get your slope, okay? If you get your equation written out like this in y equals format, remember, you can always grab your slope just by looking for the item in front of x, okay? If this is slope, do you remember what this is down here? Yeah, it's your y-intercept. It's your beginning point, right? If you had to graph this, you'd be beginning at positive 1, and then you'd be doing your rise and your run slope, okay? Here's the same equation, but graphed. All right, if you notice, if we connect 2 of our points that are perfect on the grid line, you can rise 1 and you can run 2 to see that it has the same slope, okay? So one of the things we do a lot of in this unit is we compare different relationships, okay? And those relationships might be linear, right, just like this. So those things that we've been working on, those slope and the y-intercept stuff, super important to be able to find them. Super important to be able to compare them, even if they come to you in a table or a graph or an equation. Okay, but they're all linear. So the deal is you're looking to see if it forms a straight line, or you're looking to see if it's in this format, y equals mx plus b. Tables are a little trickier, but still, I think we can find constant rates. Okay, any issues with linear functions? Okay, so next page, nonlinear. A nonlinear is a function that, surprise, surprise, does not form a straight line. Okay, in science, have you worked on any graphs that came out nonlinear? Yeah, okay. Sometimes they want you to connect the dots anyway, right? So it ends up being kind of a weird looking line graph. Sometimes it wants to be a curve, okay? And what you guys are going to study next year, you're going to do a lot of these graphs down here at the bottom, okay? This one's called a quadratic. Some people call them a parabola. Okay, a parabola graph looks like this. It has what's called a vertex, and then you can see it's symmetrical on both sides, and it continues in the upwards direction. But you'll also study parabolas that actually are pointed down. The vertex is at the top, and then for whatever reason, that relationship shows the 2 sides going down. But anyway, back up to the top, okay? If it doesn't make a straight line, that means it cannot look like this in its equation form. Y equals mx plus b is only special for linear equations, right? So if you notice down here, you've got some really weird stuff going on. It's still y equals, but notice how it's x squared. Did we ever have x squared in y equals mx plus b? Okay, so again, that sets it apart just by looking at the way the equation's written. This is definitely not linear because you can see it when it's graphed, but you can also kind of see it in the equation, right? What about this one, y equals x cubed? Did we ever have any x cubes when we were doing linear equations? Okay. So in a quick reminder here at the top, it says in a nonlinear function, the rate of change is not constant, and then the graphs do not form a straight line. Okay. So there's 3 examples of graphs, again, that you'll study once you get to high school. But I wanted you to see them because the equations are very, very different from what we're used to doing for linear. This one's called a reciprocal function. 1 over x, remember when you flip a fraction over, it's called the reciprocal. So guys, what I want you to do, I know it's not going to be super easy, but I want you to sketch. The graph doesn't have to be on there perfectly, okay? You're not really responsible to do this kind of graphing until next year. but I want you to try to get the gist of what it looks like. The reciprocal graph does have one piece of it over here, one piece over here. Are there any straight line components to it? No, not at all, okay? So on the bottom, there's two more that I wanted you to sketch. This one's called the absolute value function. Absolute value, remember, can't be negative, right? Remember doing absolute value in 7th grade? The absolute value of 5 is 5. The absolute value of negative 5 is also 5. So that's what makes this shape kind of a V shape. And I always have students who are like, hey, there's sort of a straight line there. But is it the type of straight line that we're used to for linear equations? Okay, remember linear goes in both directions forever and ever. This is a little different. Even though it's part of a line here and part of a line here, it's not one straight line. Is why we don't call it linear. And then, of course, this last one called the square root function. All right, the square root function doesn't have any negative components over here. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2, right? So that's why this graph forms this curved feature to the right. All right? So questions about linear, nonlinear? Linear means? Straight line. What if I don't give you a picture of the graph? Y equals mx plus b is what you look for. Okay? If it's nonlinear, it's definitely easy to tell just by the picture, but it also can be told just by looking at the equation. Do any of these look like y equals mx plus b? All right, then you're good to go. If I put a picture in here, there it is. So remember, the blue tab, you want to actually skip 2 pages so that we can kind of work backwards next week and throw in the first lesson and the second lesson. This is technically the 3rd lesson in your unit, so it's probably best if you skip a couple pages to put it in there.